Alright, on this video I'm going to show the various parts of the motor now that I've got it broken down. I also wanted to show this cheat sheet. This sheet basically, for me, I counted all of the teeth on the gears, and I also wanted to determine the diametral pitch of the gear teeth, and I knew it would be a standard American pitch, and it ended up being 48 pitch with a 20-degree pressure angle. These are some gauges that I've got from Boston Gear. I'm going to try and do this with one hand, but you can see how they mesh. Now it's really hard to see, but that rolls in there nice and smooth. 20-degree pressure angle, 48 pitch. So I determined that, and then I counted the teeth on the gears to obtain the ratio, and then I had all that information printed out here. And then all the rest of this text is basically a cheat sheet. When I was doing the disassembly, anytime there was some sort of a washer or a spacer or something like that, I indicated where it was located, what came off first. Did a brass washer come off first, then a fiber washer, so on and so forth. Where were the spacers? What was the orientation of the gears, and what shaft was the gear on, so that when I go to reassemble it I won't have any trouble. Also, the motor, once it's taken apart, it's hard to find any type of a witness mark from the way the parts were put together, so I end up tapping little dots on the case pieces. I don't know if you can see that. It's right there, and that way, but then that's before I even take it apart. This is the way you'll receive the motor when you buy one off of eBay. And basically the first thing I do is just start somewhere down here where I get a clean shot all the way up the case. And I either put a mark with a marker, but I cleaned the case off and polished it, so I have to end up taking a small dent into the case. I used a very small drill bit and drilled just a little dot, here on the end belt, then here up at the top of the magnet casing, then on the gearbox, all the way up. And then that way when I put it back together I can be sure that everything is lined up properly so that nothing is out of whack. Anyway, here are the parts. Here is the actual casing of the motor, showing the two magnets. They're very large ceramic magnets, very strong. And here is the motor end bell. You can see there's a bronze bushing in there, self-aligning, and that's for the tail end of the armature. Here's the top of the motor, and I don't know if you can read that. You can see MT stamped right down here. That's motor top. I've stamped that in here. I've also got a small 9 right there, indicating that there's 9 teeth on the pinion. Here's the bottom portion of the gearbox. And you can see another bronze bushing in here, which is for the output shaft, the final gear. And again, these pieces were polished. There's a couple of those marks that helped me line that back up. GBT, it's hard to read, gearbox top. Again, you can just do this with a marker. It doesn't have to be fancy. You can number them, 1 through 4, top to bottom, however you want to do it. And then I've got all the hardware laid out here. I'm also going to put a electrical connector on this so that if it ever needs to be removed or relocated, it can be unplugged rather than cutting wires and then having to resolder stuff later. So all of these motors will end up getting a connector like that on the leads with heat shrink tubing. I've also added a piece of yellow heat shrink tubing to this. When you get it, it'll have a small black piece. There's a little bit of extra room in this hole, so if you want to tighten that up, you can put a small piece of heat shrink on there and tighten that up. I'm also going to put a small little grommet here to clean up that exit hole for the wire. So I've got that laid out there. But here are the gears. Here's the armature, which is a 9-tooth pinion. I've printed that there on that epoxy. This is a 7-pole armature, and it is skewed 52 degrees. Which is 1/7 of the circle, so it gives a very smooth running, even at low voltages. I'll demonstrate that on this transformer over here. I can get it to run so slow you can count the revolutions. There's the commutator. Anyway, the pinion gear goes up here on the shaft. It had to be removed. I used this little pinion gear puller to pull that off. That way I can separate the top of the motor from the other pieces so I could polish these parts without fear of damaging the armature. So here is the first counter gear. What did I mark on here? It is a 12 on the top and a 24 on the bottom. And then the second counter gear is a 12 on the top and a 40. These are two combination gears. And then the output is a 46. And then you can see I've also drilled a pinning hole through the output shaft right there in the middle of that flat. When you get yours, it will not have a hole, though it is very easy to do that. I'll show how to do that on the drill press. But they've already machined a flat on there to receive a set screw. And I go ahead and drill the hole there to help pin some other pieces on if it needs it. Again, you don't have to do that. And then here are the brushes for the motor. And they end up going in these solid brass brush boxes with springs. And then, like I said, here's an assortment of different fiber washers and spacers for the shafts up here in the gearbox to get everything correctly installed. But again, all of the gear case and motor pieces are there. I've got some oil here, grease, a brush to apply the grease, the electrical connector. This hardware here is going to be used to fix the motor to the end bell. So while I had it apart, I drilled an additional hole in the end bell. That is right here at the top at the 12 o'clock position. You can see that through hole. And this bolt here, it says number 632 by 1 inch. It'll be used to create a stud there, and then this wire connector will go on there, and then the nut will hold it on there to kind of fix the wire, so if they're ever pulled on, you're not pulling directly on the exit point from the motor, so you don't do any damage to this printed circuit board piece that the brush housings are mounted to.